Hello everyone, today let's solve the problem number 73, set matrix 0. So what the question states here, we have been given m into n matrix. You can clearly see here we have been given, let's come to the example part here. We have been given an m into n matrix. If any element is 0, then we have to set its entire row and column to 0. So let me come here, let's discuss the first example here. So one more thing, we have to do this in place using the constant space, right? So we shouldn't modify, or we shouldn't we shouldn't consider any extra array, right? So we just do this one in place using the constant space. That's what they've given in the question, right? The question is very simple. We have been given m into n matrix. If any element is 0 in the matrix, then we have to set its entire row and column to 0. See here, 0, we have 0 here. So we have to set this entire row and entire column to 0. So that's what they have asked in the question. Basically, when we convert this one, means when we set this one, set this row to entirely 0, and when we set this column to entirely 0, this becomes 1 0 1 0 0 0 1 0 1, right? So see here, 1 0 1, this one 0, this becomes 0 0 0, and this becomes 1 0 1. This will remain constant. So 1 0 1, not constant, basically this will be converted to 0 as well, right? This will be 1 0 1 basically. So the output that we need to get here is 1 0 1 0 0 1 0 1. How? After changing this one, we have 0 here, so we have to convert this entire row to 0 and entire column to 0, right? I hope this is clear. Let's come to the second part here, or the second example. Just give me a second here. Yeah, we have 0 here, so here entire this row will be set to 0 and this row will be set to 0 as well. And we have 0, we already have 0 here as well, so we have to set this row is entirely 0, and we have to set this column 0 as well, right? This column 0 as well. So the output that we need to get here is 0 0 0 0 3 4 0 4 5 2. Sorry, this one has to be set to 0, right? 0 4 5 0 0 3 1 0. So that's what the output that we need to get here. So I hope the question is completely clear. They have given us wonderful examples just for the sake of understanding, right? So I hope the question is completely clear, and what we need to do is completely clear as well. So first, let's discuss the approach, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach first. So the first thing that we need to note down here is we'll be going with the in-place marking approach. Why we are going with the in-place marker here? Because we just have to play this one, change in place, right? So we just have to modify in place. We shouldn't be considering extra this one, result array or something like that, right? So we just have to change in place. So we'll be going with the in-place marker. So I have considered the same first example so that it will be easier to understand. So we have already discussed this one, 1 1 1 1 0 1 and 1 1 1 we have. So this entire row, this entire column will be converted to 0, and this entire row will be converted to 0 as well. After converting, we get 1 0 1 0 0 and 1 0 1, right? So this is how we got the output. We have already discussed this one. Let's move on with the step-by-step execution here. So same first example that we considered here. So here the first step is we have to check if the first row or the first column contain 0. No, here in this case, first row as well as the first column doesn't contain 0, right? First row no 0, first column no 0. So first row 0 will be false, first column 0 will be false. So this is first step. Let's go on with the second step. I hope the first step is completely clear, easy to understand, right? So second step is here we have to traverse the matrix. When I say we have to traverse the matrix, at matrix 1 1 equals 0, here in this case we have matrix of 1 1 is 0, means we are marking the row 1 and column 1 by setting matrix of 1 0 to 0 and matrix of 0 1 to 0. So here in this case, at matrix of 1 1 0, we are setting matrix of 1 1 to 0, and we are marking row 1 and column 1 by setting matrix 1 0 to 0 and matrix of 0 1 to 0. Here I'm speaking of this one. We have here, we can write in this way, right? So just give me a second here. So here this is 1 1 1 1 0 1 1 1 1. So this is 0 comma 0 0 comma 1 0 comma 2 1 comma 0 1 comma 1 1 comma 2 2 comma 0 2 comma 1 and 2 comma 2. here. So here matrix 1 1 is 0, 1 comma 1 is 0. The coordinates 1 comma 1 is basically 0. That's what here at matrix 1 comma 1 is 0. We are marking the row 1 and column 1 by setting matrix 1 0 0 and matrix 0 1 to 0. Now matrix becomes 1 0 1 0 0 1 1 0 1, right? Matrix 1 0 1 0 0 1 and this one 1 1 1 means here in this case 1 0 1, this we will set this one to 0, this one also we will set this one to 0, means 1 comma 0 and 0 comma 1 we are setting this one to 0 as we have 0 at 1 comma 1. That's what we are doing here. That is the reason we got here 1 0 1 0 0 1 and triple 1 here in this case. The next step is we have to traverse again, means we have to set this one as well, right? So here we have successfully set this one. What do we call this one 0 comma 1 and 1 comma 0 we have successfully set, and we also have to set 1 comma 2 and this one 2 comma 1 as well, right, to 0. That's what we will be doing in the third step. So we will traverse again for matrix 1 comma 1. Since matrix 1 comma 0 is 0 or matrix 0 comma 1 is 0, we will set the matrix 1 comma 1 equals 0. Similarly set matrix 1 comma 2 and matrix 2 comma 1. This one I'm speaking of. Matrix 1 comma 2 means here this one. Consider this one. 1 comma 2 is this one and matrix 2 comma 1 is this one. Both are having 1, so we will convert this one to 0 or we'll set this one to the 0 basically. Now matrix becomes 1 0 1 0 0 1 and 1 1 1. So this is what the output that we wanted, right? So here in this case what we did, since first row and the first column are false, we don't have to change to first row or column, right? So the final output that we need that we got here is 1 0 1 0 0 0 and 1 0 1. So which is equivalent to the output that we that they have given for the first example in the question. 1 0 1 this one 0 0 0 and 1 0 1, right? So this is the output that we had to get and this is the output that we got. I mean this is the output that we got which is equivalent to the output that they have given for the example 1 in the question. So I hope the approach is completely clear, right? Now as we are completely familiar with the approach, let's discuss the edge cases one by one very quickly. So the first edge case is for the 0 in first row only. So when I say 0 in first row only, we have 0 in the first row only, right? Here this one you can clearly see 0 comma 1 2 comma 3 0 comma 1 2 comma 3. So the output that we got here is 0 comma 0 and 0 comma 3. This one I'm speaking of, right? 0 comma 0 and 0 comma 3. So let's come to the second part here, 0 in last cell. So here we have 0 in the last cell. This one I'm speaking of, 0 in the last cell. So 1 comma 2 and 3 comma 0. When I say 1 comma 2 and 3 comma 0, 0 we have in the last cell. So the output that we need to get here is 1 comma 0 0 comma 0. So see here 1 3 0 we have. So this one we have to set to 0 and this one we have to set to 0, column as well as the row, right? So now after setting this one we get this one 0 0, right? That's what 1 comma 0 and 0 comma 0. Same goes with this one as well, 0 comma 1 2 comma 3 0 1 2 3. So we have to set this one and this one to 0. This will be 0 0 0 3, right? 0 0 0 3. So this is fine. Let's move on with the third edge case here, single element matrix, nothing but non-zero. We don't have any zeros here, so we'll return the same thing, 1 as output. So single element matrix with 0. When we have 0, we'll set have the because we have the single element that to 0, we'll return the same thing here as well. So let's move on with the fifth edge case here, 0 in the first row, multi-column matrix. When we have the multi-column, see here 1 0 means 2 columns we have in this case, so we will convert this one as 0 as well. Row and column both we have to write. So in this case it will be 0 0. That's what we have returned here, right? So these are the 5 edge cases that we need to consider here. The first edge case is for the 0 in first row only. The second edge case is for the 0 in last cell. The third edge case is for the single element matrix. The fourth edge case is for the single element matrix 0. The third edge case is for the single element matrix non-zero. The fourth edge case is for the single element matrix 0, and the fifth edge case is for the 0 in first row multi-column matrix, right? So these are the 5 edge cases that we need to keep in mind, right? So these are the 5 edge cases that we need to keep in mind. So now we are completely familiar with the edge cases as well as the approach. We are good to write the code. Let's start writing the code now. So let's write the code step by step. The first thing is let's get the rows and let's initialize the rows and columns. So we need the rows and columns, right? So let me initialize the rows to length of the matrix and columns to matrix of 0 dot length. So this is fine. So the next step here is I'll just take two more variables here, which is of the type boolean. I'll just go with first row 0. So we are just going with the same thing that we discussed on the approach. So we are just articulating the same thing in the form of code here. So we have to check if the first row has any 0. We have to check if the first column has any 0. Then we have to mark the zeros in the first row and column for the rest of the matrix, right? So then let's set the matrix cells to 0 based on the markers. Finally, we have to get the 0 out the first row and first column if needed, right? So these are the steps that we need to go with. Initially, let's set the first row to 0. Let's not let's do it step by step. I mean, so not 0 here, boolean value we are considering right here. So let me initialize this one to the false and let me go with first column 0. Let's set this one to false as well. So this is fine. So let's come to the first step here, step 1. So let's check if the first row has any 0. So let's check if the first row has any 0. Means let's check if the first row has any 0. Let's also check if the first column has any 0. First, let's check if the first row has any 0. So I'll just go with for c equals 0, c less than columns here, c plus plus. This is fine. So within this for loop, I'll just go with if condition here. If matrix of 0 c this one equals 0, then what we will do, we will set the first row 0 to true if it contains 0. We are comparing here, right? Matrix of 0 c, this one. So we are comparing. We will set the first row 0. We have initialized this one initially with false. So we'll set this one to true if it is 0, if the first row contains any 0 here. So then let me give break if it contains, right? Let's go with the make use of the break statement. Let me come out of this for loop entirely. Next, we successfully checked if the first row has any 0. Then we have to check for this one as well. What do you call? For the column as well, right? So we have to check if the first column has any 0. So let me paste it over here in this case. And this one, let me go with row here. Row. This one instead of columns, I'll just go with rows. This is fine. So this one is row plus plus. This is fine. If matrix of this one 0, row 0, this one if it is equal to 0, then what we will do, we'll set the this one first column 0. This one we have initialized this one to false. Let's set this one to true. This is fine. Then let's break. Same thing we are doing for the column. So first we checked if the first row has any 0. Now from the line number 13 to 18, what we are doing, we are checking if first column has any 0. Let me come out of this loop entirely. So the next step is, if you remember, we have to mark the zeros in the first row and the column for the rest of the matrix. So let's go with the for loop here. We are just marking the zeros in the first row and the column for the rest of the matrix, right? So in this case, I will be going with the simple 2 for loop. So the first for loop here is int r equals 1, r less than rows. We have to check for the rest of the matrix, right? So I'll just go with r plus plus. Same goes with the column as well. Individual column, so individual cell on the column. So this will be int c equals 1, c less than equal c plus plus. So this is fine. So here within this, we will be writing the simple if condition here. If matrix of r c this one equals 0, then what we will do, matrix of r 0, we will initialize this one to 0. And one more thing, matrix of this one 0 C, row and column both we are considering individual cells in the rows and column. So we have to convert this one right to the zeros. We have to mark the zeros in the first row and the column for the rest of the matrix as well, right? If we have found the 0 in first row and first column, right? So that's what we have done this one successfully. Let me come out of this loop entirely. So the next step here is what we have to do. Next step, we have to set the matrix cells to 0 based on the markers. So if we have 0 next to it, next row and column, right, we have to set that one as well. I mean, if we have 0, we have to set the cell next to it, either it may be right side, left, up or down, right? We have to set that one to 0 as well, right? We have to set the matrix cells to 0 based on the markers from the previous step. Whatever the markers we have, if we have 0, based on that we have to set the matrix cells to 0. Again, let me copy the same thing over here and make the necessary changes. So here in this case, so let me come out of this one and let me paste it over here. This will be r equals 1, r less than rows, r plus. This remains same. C equals 1, c less than a column, c plus plus. This also remains same. If matrix of r 0, so let me write the condition here. So this one, let me make it here itself. If matrix of r, instead of c, I'll just consider 0 here. This is 0, or matrix of C 0, this is 0, then what we will do, we'll set the matrix of RC to 0. So here let me delete this one. Let me go with matrix of RC. Let's assign this one to the 0. Means we are setting the matrix cells to 0 based on the markers from the previous step. So from this one, right? Whatever we have written the code from line number 20 to 27. So this is fine. Let me come out of this loop entirely. So let's go with the final step, not the final step, fifth step here. So we have to take the 0 out the first row if needed. So we have to take the 0 out the first row if needed. Also we have to take the 0 out the first column if needed. First, let's write the code for taking the 0 out the first row if needed. So here let me write the simple if condition here. If let me copy this one, first row 0, this one, right? So we are going with the rows. We are taking the 0 out the first row if needed. So I'll just go with here, if first row 0, this one, then what we will do, I'll just go with the simple for loop here, and c equals 0, c less than columns, c plus plus. This is fine. And let me set the matrix of 0 c, this one to 0. This is fine. So let me come out of this loop entirely. Same thing, we have to take the 0 out the first column if needed. So let me copy the same thing and make the necessary changes here. So let me come here and let me paste the same thing over here. Instead of first row 0 here, I'll just copy this one and let me paste it over here. This will be first column 0. This remains same. So this we have to change this one to row, right? So r less than, instead of columns, I'll just make this one rows. This is fine. So let's increment the row r plus plus. So here instead of matrix of 0c, this will be r 0. This one we are assigning this one to the 0. Basically this is it for the code. We went step by step. So I'll quickly said what we have done. So let me format the code once so that this looks good. So this first step, this goes with the initialization. The second step here, in this case, what we did here, we are checking if the first row has any 0. Accordingly, with the approach we have went right step by step. We have done this one step by step. This one from line number 6 to line number 11, we are checking if the first row has any 0. So from line number 13 to 18, what we are doing, we are checking if first column has any 0, right? After checking for first row and first column, if it has any 0, then what we are doing here, from the line number 20 to 27, what we are doing, we are marking the zeros in the first row and column for the rest of the matrix. We know this one, right? So let's come to the line number 29 here. From 29 to 35, what we have done here, we are setting the matrix cells to 0 based on the markers. Based on the markers means whatever the code that we have written, this one from 20 to 27. Based on that, we are setting the matrix cells to 0, right? Let's come to the fifth step here. Fifth step, what we are doing here, we are taking 0 out the first row if needed. Here in this case, line number 37 to 41, we are taking the 0 out the first row if needed, first column if needed, from 29 to 35. From we are taking the 0 out the first row if needed, from 37 to 41, right? So the final step here is last two steps, sorry. So this one has to be basically, did I write this one again? First row tar equals 1, what is this? So this one, sorry, I got confused here. This one, did I write this one? Just give me a second here. So yeah, we are marking this one. So yeah, here I got confused. Basically, these two are the steps. From 37 to 41, what we are doing. So we are taking the 0 out the first row if needed, and from 43 to 47, what we are doing, we are taking the 0 out the first column if needed. So this is it for the code. Let me format the code once and let me hit the run button. So I hope this works. Let's see. So we have some error here. Index 3 out of bounds. Length 3. What is the output that we are getting? We are not even getting the output. So here we are getting the error, right? Line number 31. Let's check what we have done wrong here. So here I have done a mistake. Basically, this if condition has to be matrix of R0 equals 0 or matrix of 0C here on this case. So this one has to be 0C. This is equal to 0, then only we have to set the matrix of RC to 0. So this one had typed wrong. Basically, let me hit the run button. Let's see whether this works. I hope this works. Let's see. So yeah, now you can clearly see here the sample test cases are getting passed. So let me hit the submit button very quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case, right? So the code works absolutely correct on this case. Let's discuss the complexities for the code that we have written very quickly. So here the approach that we went with here is in place marker. We know that one, right? First row bar, column as flags, right? Basically, we can just call this one as in place marker. The approach that we went with here is in place marker. So what would be the time complexity here? The overall time complexity would be big O of m into n. So overall time complexity would be big O of m into n. So when I say overall time complexity would be big O of m into n, so why it is big O of m into n? Basically, we are traversing the matrix 2 times, right? So no nested per cell beyond big O of 1 operations, right? So overall time complexity would be big O of m into n, quite obviously. We know that we are traversing matrix 2 times, right? So this is fine. So let's move on with the space complexity here. What is the space complexity for the code that we have written here? The space complexity is big O of 1. Why it is big O of 1? Only 2 Boolean variables are being used here, right? Only 2 Boolean variables are being used. First column, this one I'm speaking of. First row 0, first column 0. Only 2 Boolean variables are being used here. Nothing but this is constant space, and no extra matrix or arrays are being used here. So we are going with the in place marking or in place modifications. So the time space complexity remains big O of 1, right? So the time complexity for the code that we have written is big O of m into n, and the space complexity for the code that we have written is big O of 1. I hope complexities are completely clear, and I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.